Hi folks, welcome to Rob's Arcade Den Repair and Tech Talk number 2. In this video we'll be looking at Tehkan Pleiades. Pleiades, or commonly known as Pleiades, was the 1981 follow-up to the very successful Phoenix, a fixed shooter released the previous year. This board came in straight after sale as it was sold as untested. It had its Intel 8085 CPU and another unknown chip missing. In certain places the board was suffering from quite bad corrosion. After ordering the new CPU, I downloaded the schematics and found that the missing chip and two others on the board, marked X, Y and Z, are actually not revealed. This method was probably employed to try and stop bootleggers back in the day copying the boards, or an attempt to stop operators converting Phoenix boards to Pleiades. 5 minutes after searching the arcade forums, it come up with the information, and a 74LS669 was ordered and placed onto the board. The repair picks up from this point. After switching the game on for the first time, I was presented with just a static screen. It was either blue or blue with stripes across it. After around 5 minutes, the screen started to flicker violently and at some point lost its sync. The board was also making random sounds. I initially tested the crystal on the board, which was delivering the correct 11 MHz for the system. I then checked the outputs of the 163 counters. These provide the horizontal and vertical counts for the entire system, which affects the screen and all the timings. The outputs of these chips should be subdivisions of each other, but instead of set subdivisions they were erratically going in and out of sync. On the LS163s at location 20 and 38, which control the vertical counts. These two chips are fed by a common clock on pin 2. This clock originates from an LS74 at location 12, pin 6. After testing this pin, I found out that the clock was also erratic, and I also found that all the outputs on the LS74 at location 12 were faulty. The chip was replaced, which fixed the flickering of the screen. Before commencing with the fault finding, I went across the board, and some of the chips that were really corroded I just replaced. There were some dead pins on the CPU which I traced to one of the edge connectors and found that there were some traces that were broke. These were repaired. So after changing some of the chips in there, particularly the ones that look quite corroded, and also finding that we had some broken traces on this multi-connector which I've repaired. The volume's a bit flaky, but we still haven't got visual, but the game is running. As we can hear the audio for the track mode. So something's happening. So we're just having a look on the board, and these two chips here are colour proms, and the outputs on them seem to be just fixed, which is probably why we've got just a blue display. So I've had a look on the diagrams, and just before those chips, if we look on the schematic here, so I've looked at the 7407 and worked my way back. We have signals coming in from this LS174 But then we look at these here, these LS157s, and the top one, which is chip 11, we've got signals coming into the LS174 on pins 4 and 3. But if we look at the lower one, which is in location 3, we've got 3 signals coming out of that on pin 9, 7 and 4, and go into the LS174 at pins 14, 13 and 11. They're just like either dead or floating. So I've checked the inputs on this chip, which are coming through a multi-connector, and they come from the other board. So we've got these LIN signals, and all of them seem to be floating or dead. So we're going to trace them onto the other board and start doing some testing there. So these are the signals on the LS174, which is coming in from the first LS157 on pins 4 and 3. You can see that's pin 4 and pin 3. They look quite healthy. So if we look at the 3 signals coming from the other LS157, these are on pins 14, 13 and 11. So if we just have a look at those, that's pin 14, 13 and 11. Not much happening. So if we now look at some of the inputs on that LS157 at location 3. So have a look. This is pin 3 coming in from the other board. As you can see, it's pretty much grounded with a load of noise on it. This is pin 5, same, 6, the same. So it's looking like there's something which those are tied to on the other board, which isn't really doing anything. So we're going to have a look at those. So these LIN signals, they come in here and go up to this circuitry, which is round the foreground and background ROMs for the graphics, and they seem to originate from this LS174 at location 16. And then there is also similar setup where we've got the other LIN signals coming in here and go up. To say it's very similar. So yeah, it's to do with foreground and background graphics ROMs. Now, just checking on these LS174s, we've got this CK clock signal, what comes in at 9, and that's also common on the chip above it, which is also LS174 at 35, and that clock signal is also present on the LS374 pin 11. Now if we have a look at that signal, so we're looking at pin 9 on 34, and all we get is that, which that's no clock signal. so it's not going to work. Now that could possibly be a break in a track again, but that's for something for us to investigate. So that's one of the clock signals, and the other one, going to the other section, is on 16. Is that, which just seems to be held high, so we'll be looking at that as well. So those clock signals, this CHS00 and CHS10, they all originate from all this glue logic here, which is going to take a little bit of working out, but it comes through all these gates here, and then it comes back from the other board again. So it might be worth me just testing those coming into there off the other board. But the other inputs to these all come from the same signal, down and across here, and seem to originate from this here. So it looks like I've got quite a few gates to start testing. Fun. Right, I'll start doing some probing. So I've been analysing this collection of logic gates here, and I noticed when I got the board that one of those two chips has already been replaced, which is here, and this one here is obviously the original one, which is extremely corroded. Now I found the outputs on this one not really doing anything by the truth tables of a exclusive OR gate. Now this one is an LS136, and this one's been replaced, which should also be an LS136, but it's been replaced with an LS86, which is an exclusive OR gate, and they're pin-to-pin compatible. But this one, I believe, has open collectors. So this is the wrong one, really. Unfortunately, I don't have any, so I'm going to have to order some. We'll put the proper chip in and see what happens. Meanwhile, we have this here sound chip out of the Pleiades board, and I believe these are quite hard to get, and unfortunately it's always the hard ones or rare chips which the legs just corrode and drop off them. So what I normally do in this situation, hopefully it works, we're not too sure, but it's worth a go. So what I normally use is, an IC turned socket, and put this in and solder what is left of the pins onto the socket, which then fixes back in a normal socket on the board. I haven't got any turn sockets for these, but I have got these, so I'm just going to cut them down to size and have a go at soldering that chip into them. so hopefully it'll save it. So a bit of progress with the sound chip. If we switch 7 on, you can hear that we've now got the music and sound effects. However, I'll just turn this off so I can talk. Going back to these chips here, we found out that this is an 86 and it should be a 136. This is obviously a 136, but I'm suspecting it's faulty. Anyway, because they're on order, I've just got an 86 and we're just going to basically piggyback it, and even though it's the wrong chip, it's corrupt, but you can see that the game's running. So we're missing some elements, but it's coming back to life. Now, it does credit up, but as you can see, without pressing any controls, it starts, but it shoves the spaceship to the left, and I've got no control over it. So something's forcing the movement. You just constantly go left. So while we're waiting for other chips, I'm going to have a look at that and see if we can get that sorted. Looking at the inputs here, we've got the inputs coming in. They go through this resistor pack here, and they all go into a LS157, and the outputs of that are the 1Y, 2Y, 3Y and 4Y on pins 4, 7, 9 and 12, and they go into this 244 at pins 6, 13, 8 and 11. So I'm just going to probe them. I'm thinking that it's just stuck, the output is. It's floating. Seven is low. 9 is low. 12 is high. So I'll just have a look on the inputs of this 157. We've got 2, which is high. 5, which is high. And these will be high if they're not pressed, because when you press a button it obviously grounds. So we've got 11. That's high. And we've also got the inputs for player 2 if it's a cocktail. I'll just check these. Got 3 high again. Six is also high. 10 is also high. 13 also high. So I'm thinking that it's most likely that there's something wrong with that LS157, because it's just knocking out rubbish. We've already changed the 31 after it, which is the 244, because that was really corroded. So we're going to change that one. So just to test if the inputs are working, on the input side of the LS157, if I put the probe on pin 2, and you can see it's high, this is the trace for the fire button. So if I press the fire button on my control pad, you will see as I press it, it goes low, which is what it should do. So let's just try one of the others. We've got right, which is on pin 5. So if we hold it there, and as you can see that works. And we have left on 11. And as you can see that also works. So everything's working on the input, but it seems that nothing is working on the outputs. So that's pin 4 on the output, and I'm pressing buttons and it's not doing anything. 6, 7, same again, nothing. 9, nothing. And 12, nothing. So I think we can safely say that 157 is has had it. So we've swapped that LS157 out, and I'll credit it up. The screen seems to be gradually coming back to life again. I think it's actually the ribbon cables between the boards, but that's something else to look for. So we credit it, and I'll press start on the controller, and as you can see we can move now left and right. It would also fire as well, but because of the graphics problems you can't really see it at the moment. Get in there. So we're looking back at these signals again here. Now we've got kind of most of the kind of game visual running. We're going to go back to these LS157s at location 11 and 3. Now, before we had some of the signals missing on 3 coming in, and now we haven't. So some of the signals are there, some of them are missing. And if we look at these, you've got these 3 groups of inputs. These lin, and then there's a number after them, and they're grouped in 3s. And looking on pins 3, 6 and 10, if I bring down here, that's 3, 6 and 10, which seem to be all very healthy. And then if we look at the other ones, which is pins 11, 5 and 2, so this is 11, this is 2, and this is 5. They're not doing much at all, so we'll look and see what they're anchored to on the other board. Right, I've just been probing with the oscilloscope, and we seem to have a few problems here, and I think partly some of it is down to potentially breaks in the tracks going to this connector. You know, it's the same as the problem we had here, because the signals that we have missing on this chip, the ones that we've just tested, they come directly through this connector from this chip here, and those signals are sorry, this one, these signals are present coming out of this chip, but as soon as they've got from there onto this board, they've disappeared. So we're going to have to do some continuity checks all the way through here. It's most likely it's the connections, possibly here yet again, where it was quite corroded, this board. So that's one thing. But going back onto the schematic, we have this clock which is shared by a number of different ICs, and that goes along here, and it's this CHS10. Now going back to those chips we've just got the right chips for, we've replaced, they've now made, because of the right chip, they've made this part of the circuit now work properly. And I've just been looking at these chips here, which is in location 4, and that is it's a 74 LS 00, which is here, and just looking at pins 1, 2 and 3, if we go on to here, pins 1, 2 and 3, we'll go across here, and that is that signal for the clock, and we have signal coming in on 1, signal coming in on 2, and so we should get something what resembles some kind of clock on the output. And if I show you now, it's definitely not a clock we're getting. So that's pin 1, that's pin 2, and the output of those is that, which is just, it's just not, the pin isn't being driven properly. Now it could be something pulling that down or interfering with it down the chain, but it's most likely that chip. So what I'm gonna do is I'm gonna piggyback a chip, but pull that output pin so it's not touching this one, and stick the oscilloscope probe on it then and see what the output looks like. Right, piggybacking the chip just wasn't working, but what I've done is I've just clipped that output pin 3, which you can see here, and interestingly, without that, we've got the right colours on the screen now. Obviously we're still missing the background graphics, but I think we're on to I think we're on to something now. So I don't think we've got far to go. So I think what I'm going to do is I'm just going to remove that chip and put a new one in. So we changed the 74 LS00, and it's looking like we're almost there. We've got some weird graphic issue going on at the top of the screen, but it's all playing. Got a few sounds missing, but we're almost home and dry now. It's issues on game boards like this where you have to really analyse logic gates and signals and know how the logic chips work. We're presented here with what basically is a fully working game. This fault doesn't affect the gameplay or sounds or anything apart from creating this interference at the top of the screen. At this point there's obviously some kind of blanking signal what's missing from somewhere on the board. So just carrying on with the repair, as you can see, as I mentioned earlier, that we got this kind of like graphical interference at the top of the screen. So I've just been looking around the schematic, and come over to here, and I've just been kind of probing around, and we have these two signals coming up out of this LS74, and one comes along here into pin 13 and comes out of 9 here into pin 12 of 37, which is a NAND gate, and it creates this signal here in H. I'm presuming that stands for horizontal 0 0. So let's have a look on the oscilloscope at 12 and 13 and 11. So the inputs coming in, we have, firstly let's have a look at the LS74. We have pin 2, which we can see there's a nice pulse there. And pin 9, yet again we can see a good pulse. So pin 2 of that chip goes into the NAND at 13. And we can see it's present. And then the other one, which is on pin 9, goes into 12, which isn't present. It's just coming up literally like it's only around about a volt. Now the output, we do get an output, which is that, which looks healthy, but it's not the right output. So somewhere between the LS74, pin 9 and pin 12 of this chip, there's got to be a break somewhere. I'll try and jump this so you can see what the outcome is on the screen. Bear with me. So I'm going to jump it now, and as you can see, it disappears. Back on again, back off. As you can see, on, off. So I'm going to have to find out where that break is. So I've done a bit of a continuity check. So it comes out of 9 here to this via here, and it runs all the way across to this via here, and I have continuity there. And then it comes across the top of the board, sorry, it goes to there, and it runs down here on the top of the board and goes down to this via here, and between that point and that point there's no continuity, so there's a break down that trace somewhere. Now the breaks I had with the other traces on this board, I've held these boards up to the light and you can literally not see any kind of physical break at all. It's got to be like some kind of hairline fracture. So basically I'm going to solder a wire from that via to that via there, and that should do the trick. So we put a jumper wire in between the two vias, and as you can see, as we confirmed last time with that connection, we've got no more interference, so the game's finally running. Now, as far as the actual game's concerned now, it's all done, but we just got to sort out the sound. So we've got a few sounds missing, which is the explosion and the fire sound, which use I believe a 4006 IC, and we've got a faulty volume pot on there as well, which will be a very straightforward repair. So let's get this thing done and dusted. So I've just piggybacked the 4066 chip here, and if I just set this up, credit it up, we now have the fire sound and the explosion sound back.
There we go.